Hi, my name is Raul. Contrary to popular belief, I am not a real person, although I know the shades and the hair most definitely throw people off, but I am not real. However, I am on this video to tell you and remind you of your essential question for this particular part of the video. And Mr. Motter, the genius himself, is going to explain to you the information in this section. And the question that you're going to be able to answer is this: how do you find the surface area of a prism? Good luck. Peace.
Yeah, what's up, kids? Hey, I heard you guys just met my friend Raul. That's pretty cool. He's a good dude. We cut off his hair so you can barely see him because his hair was out of control. So we said that is gone. Anyways, he told you exactly what this video is going to be on. It's going to be on surface area. How do you find the surface area of what we call prisms? In fact, this entire 3-section unit is going to be on finding the surface area of solids. And what is surface area? Well, here you can see the words. Surface area basically is this. If you think of a gift that you would get at birthday, or you get an anniversary gift for your parents, or a birthday gift for your brother, or Christmas time, or whatever holiday you celebrate, if you actually get a gift that is wrapped with wrapping paper, picture that wrapping paper as the surface area of the actual solid. Whether it be a box, like just a simple little box like this, if you wrap everything around this box and you pull that paper off, forget the overlap, I know, don't get crazy with me now. If you just had the exact piece of paper here, the exact piece of paper here, the one on the bottom, one on the top, one on the back, and one on this side, if you could kind of find the area of each of those shapes, that would be the total surface area of this particular solid figure. And there's many different kinds of solid figures, but that is the concept. We're finding the total surface area of these particular shapes. So, what I'm going to recommend that you do, sorry Raul, I got to steal something. I'm going to take Raul's 3D glasses. My recommendation, people, would be to get out your 3D glasses, because we're going to start looking at 3-dimensional shapes, and oh baby, get ready, because they're going to pop out, they're going to pop right out at you, and you're going to be like, whoa, this is crazy, what's happening? It's going to be fun. So we're going to find the surface area, something called lateral surface area, which leads then into total surface area of these particular solids. And this video, again, is going to be on prisms. So, look into my eye. Let's do it. All right, so here we go. Let's get into the surface area. So if I move this aside, sorry Raul, there it goes. Here's the first definition I want you to put into your foldable, actually, yep, on the foldable where it says prisms, that's at the very bottom, fold everything else up. In prisms, here's the first thing I want you to put. Polyhedra. Polyhedra is what we're talking about in this section, really, where it means many faces. The word poly means many. Poly is many. Hedra actually means faces. So many faces is what this means. In terms of a solid, it's a solid figure with flat faces. So we're not talking about like something curved, like I don't know, like a silo of a barn or something. We're not talking about that. What we're talking about is flat surface shapes. Now, with this idea, you have a bunch of them. I have one right here that I can show you. There's an example of one that actually is I kind of drew right up here on the screen in a 2-dimensional world. But if you got these buddies on, it pops right out at you. Pretty cool. So this is your 3D shape that actually I'm going to show you what's going on with this. Now, in this shape, it is called a prism. Matter of fact, more particularly, it's called a rectangular right prism, because what's happening is all of these particular sides here are coming together to form right angles. So this is a right angle, this is a right angle right here, so is the one in the back, that's a right angle. They're all right angles. It's a right rectangular prism. Now you can have other shapes, but in this section and throughout, you're going to kind of, oh, I hate to say this, you're going to assume that these things are right angles. They're all right rectangular prisms. That being said, here's a couple definitions you need to write down and know. Because in every particular prism, they always will have 2 congruent parallel faces. So there's 2 of them that they call faces. And the most important thing about it is what's here in red. The name of the face is actually what determines the name of the prism. Here's what I mean. So if this guy right here is shown to you, that is a square. So this thing is called a regular square, a square prism is all it's called, a square prism. This one right here, if you look at the base, boom, that is a triangle. So that is called a triangular prism. This one right here is called, boom, that's called a hexagonal prism, because the base is a hexagon. So you see the one base right there, another base on the other side is exactly like it. So that is a hexagonal prism. This might be hard to see. This one here, it's a piece of block. It is a solid for sure. That kind of might be hard to see, but you can see it's an octagon. That's called an octagonal prism. So whatever the base is, that determines the name of it. So if I told you nonagonal prism, you should think, oh, that's a particular prism that has a base that has 9 sides. If I told you heptagonal prism, you should be thinking, oh, what does that mean? Oh, that's 7 sides. If I said hexagonal, well, I already did that. If I said dodecagonal, if I said pentadecagonal, you should know exactly what that means now. So that being said, here's a couple other things about it. Well, now we talked about base. We got that. Check that off. There's two other things in prisms that you're going to hear and talk about. The non-bases are called what we say lateral faces. So if this right here is one of the bases of my shape, and this one here is another base of my shape, that means the other 4 faces that go around. The front face, again, if you got your 3D glasses on, you'll see it. The front face, the top face, the bottom face, and the one in the very back. Those 4, the ones that are not the actual bases, they're called lateral faces. So there's an example of a lateral face right there. So if I looked at this hexagonal prism, it's all of those rectangular things that's kind of facing you right now that I'm twisting this around. It's not the hexagon. It's not the hexagon. It's the other things. That's called the lateral faces. So that's the idea there. Now, not that this means so much, but you will be talking about this throughout this unit. Lateral edges are these edges right here that connect the vertices. So that's a lateral edge, that's a lateral edge, that's a lateral edge, so on and so forth. And you can see the definition. There are segments that connect the vertices. They're called the lateral edges. So there's a couple definitions of what prisms are. Now, how do we find the surface area, though, of a rectangular prism, a square prism, a hexagonal prism, whatever? Here we go. Move this aside. So surface area of a prism. There's 2 things we're going to talk about in this section. You're going to see in your book, it's going to ask you to find the LA of the shape. The LA of the shape, guys, is the lateral surface area. And what that is the area of all of the lateral faces. It's the sum of all of those areas. Ultimate goal, though, is to find the total surface area of the entire shape, of the entire solid, sorry. So that's called TA. In the book, when it asks you to find TA, that stands for total surface area. LA stands for lateral surface area. So how do you find the lateral surface area? Well, I just said, you find the sum of all of the lateral faces. And here's what's really cool. If you remember, go back and look at the video, if you look at the lateral faces of all the shapes that I showed you, every one of them, I'll use this as an example, this triangular prism, every one of the lateral faces is what kind of shape? You got it, a rectangle. Every one of them, all 3 of these are rectangles. By the way, all 6 of these lateral faces on this regular hexagon here, or hexagonal prism, they are all rectangles. That's pretty cool. So that's not too hard to find the area of. You just got to find the area of all those rectangles and then just add them up. Or the other idea that you can do is find the perimeter of the base, add up all the numbers, find the perimeter, and then take that times the distance between the bases. The distance between the bases from this finger right there to this finger right here, that distance right there, from one base to the other, we call that the height. But that certainly don't take it literally, because that's not height, that's a cross. That's a horizontal distance. So regardless of how you look at it, it's the distance from one base to the other one. That's what it's called. So perimeter of the base times the distance between the 2 bases, that will also help you find the lateral surface area. Again, total surface area is the goal. So you're going to find the lateral surface area then by doing one of these 2 methods right here. And then you're going to find the area of both bases, which is kind of cool because each base, if you remember, each base is congruent. So this base is congruent to the one right there. Both of these are congruent to each other. So really all you have to do, guys, is find the area of one and then take that times 2 because they're both exactly the same area. So that's exactly what I'm showing you down here. You're going to see throughout this chapter that there's a script capital B that they use, and that will always, every time you see it, it's always going to mean area of the base. So I can't be specific here because how you find the area of the base of this is different than how you find the area of the base of this, is different than how you find the area of the base of this. So that's why it's got to be generic in general. You have to use the right formula to find the area of the base. Oh, that should ring a bell. We just took a chapter test on that. So find the area of the base, take that times 2, add that to the lateral surface area, and bada bing, you got your total surface area. So there you go. That's exactly how you do it. So let's see now how we can apply this to a couple examples. So here's one of the examples we're going to do. You see this triangular base, so that is called a triangular prism. And you see certain side lengths that's given, and here's the 2 questions we're going to talk about. We're going to find the lateral surface area of this triangular prism, and then we're going to come down here and then find the total surface area of that triangular prism. So basically, if this was the shape, you want to find the area of this, how many little square units you can put in that triangle, how many little square units you can put in this triangle, how many little square units you can put in this face, put on this face, and put on this face back here. And you add all 5 of those up, that's your total surface area. Again, it's the amount of wrapping paper that you can put on this bad boy right there. That is the idea. So, let's do it. Lateral surface area. Okay, so you can see I've done a little bit of work here. Lateral surface area, remember there's 2 ways you could do it. One, you can actually break this up with the 3 different rectangles that are the lateral faces, because that's what we're finding, lateral surface area. So the front one here, I see is just a rectangle with one base, 17, and the height, if you will, is 20. Doesn't really matter, but that's what I see, 17 times 20. There's the front one. The one on the bottom is 16 by 20 as well. This is 20 right there. So I see 16 by 20, that rectangular thing that's on the bottom. Now remember, if you look at it in a 2-dimensional world, that thing on the bottom looks like a parallelogram. But you got to remember, this is really what you're looking at. So the bottom part, this thing right here, even though it's kind of angled a little bit, the bottom part is a rectangle. So that is just base times height. So the bottom is 16 times 20, which gives me 320. And then the one in the very back is just 20 by 17. So that's another rectangle. So 20 times 17 gives me 340. I add all those up, lateral faces added together, the sum of them gives me 1,000 units squared. So that's option number 1 that you can use. I love it. Option number 2, if you find the perimeter of the actual bases, and this is 17, which makes this one over here 17, because remember this front thing, this front panel, this front lateral face is a rectangle. So if this is 17, that means this has to be 17. So what I'm looking at is the perimeter of 17 plus 16 plus 17, and that is right here, it's 50. So I take the perimeter times the actual height. Height is the distance from one base to the other one. So 20 is that, so 20 times 50 gives me 1,000. Either way, you get the answer. It doesn't honestly matter to me which way you want to do it. But if you were asking me, this is probably the easier way. Just find the perimeter, take it times the height, and you're done. That's pretty cool. So, okay, let's move on to total surface area. Now remember, that means this. You're finding the lateral surface area and adding the area of the bases. So what we've already found in this particular example, the one behind us, we found the lateral surface area to be 1,000 units squared. Remember what that represented. It represented all the stuff that I'm touching right here on this shape. That's the surface area we just found. What I'm missing though for total surface area is the actual bases, this side and this side. So I just have to find the area of one of those bases. We'll say this nice little green one right here. If I find the area of that, take it times 2, and we'll have our total surface area. So in this picture, to find the area of a triangle, because that's the base, oh, that means I have to go back to the last unit and remember, okay, oh, the area is actually just 1/2 base times height. That's the area of a triangle. That's pretty cool. So in this base, though, it's a 17, 17, 16 triangle. That's isosceles. So that means I have, 17, 17, 16. I draw my altitude down here. It bisects the side. We've seen that a bunch. That makes that 8. Oh, look, a triple. 8, 15, 17 is actually the side lengths there. So the height of this overall triangle is 15, and the base of the overall triangle is 16. Base is 16, height is 15. So 1/2 times 16 times 15 gives me 120. Wonderful. Now remember, that right there is only the area of one base. So we must, if you will, look over here. We can plug that into 120, plug that in right here for the area of the base. That's what that is, just 120. And then I got to take 2 times that, which is 240. So when I add them all together, my final answer for the total surface area, congratulations, the first one that you've done, the total surface area for this triangular prism is 1,240 units squared. That's the amount of little units, whether it was inches squared, meters squared, miles squared. That would be absurd. It would be a huge, huge triangular prism if we had 1,240 miles squared. That's unbelievable. Regardless. So that's what it is. There's your answer. So we're going to practice these a bunch in class, and we're going to practice a bunch during the night for sure. But here we go. That's it. Look forward to seeing you in class. We're going to have fun doing these. Oh yeah, by the way, don't forget, these guys right here, Raul, will be happy that you got them. See you in class. Later.